Good morning everybody. In the previous lecture we have studied what is multi-period compounding. I hope you are able to solve the problems on multi-period compounding. So I'll just revise on what is multi-period compounding and what is added to the formulas, and then we'll go ahead with the next part. So as done in multi-period compounding, we know if compounding happens more than once in a year, okay, if it happens more than once in a year, that is monthly, quarterly, half yearly, fortnightly, all those things, then we call it as multi-period compounding. Okay, so multi-period compounding is nothing but if compounding does not happen once in a year, it happens more than once in a year. So in multi-period compounding, what happens is we add a new variable called as m. Now what is m? M represents number of times the value compounds in a year. I hope you're clear with that concept. So for example, if it is monthly, then m would be 12 because there are 12 months in a year. If it is quarterly, then m would take the value of 4 because the year has 4 quarters. If it is biannually or half yearly, it may be sometimes called as half yearly, then it is 2 times in a year because half year means the year is divided into 2 parts. So it becomes half yearly. So m becomes 2. And I have already said, wherever in the formula of future value of lump sum and future value of annuity, wherever there is an I, you divide it by m, and whenever there is an n, you multiply it by m. So I hope you remember this concept. Okay, let's move on to the next part, that is effective annual rate or effective interest rate. Okay, effective annual rate, or also called as effective interest rate. Now what is this effective annual rate or effective interest rate? Okay, now whenever the compounding happens more than once in a year, okay, the nominal rate, suppose it is 12% or 10% or 8%, whatever is given, okay, you apply that. But at the end, when you calculate the amount, you find that that amount cannot be got by using the same rate of interest. That means the effective interest rate is something else. So let's try to understand what is this effective interest rate. So effective interest rate or effective annual rate, the formula is the same like your future value of lump sum formula. Future value of lump sum formula. Okay. Only difference is here we are not considering here we are not considering PV, that is present value. Okay, we are directly taking 1 plus I divided by m raised to m. We are not even considering n because n is considered as 1 itself. So directly I divided by m, 1 plus I divided by m raised to m. Please remember this, it is raised to m, not raised to n. Okay, so I'll just repeat, effective interest rate is equal to 1 plus I divided by m, the whole raised to m, minus 1, the whole minus 1. Okay, this is very important. Okay, so instead of taking present value over here, okay, we are not considering present value, we are considering minus 1. Okay, I hope you are clear with the formula. This formula is applicable to calculate the effective interest rate, where m we already know is the number of times the value compounds in a year. Now let us take a simple problem and understand what is this effective interest rate. Suppose a value compounds on a monthly basis at the rate of 10% per annum. So it is per annum, 10% rate is for the year, annum is year. Okay, calculate the effective interest rate. So how do we calculate it? As we have already studied the formula. Okay, it is EIR is equal to 1 plus I by m, the whole raised to m minus 1. So 1 plus 0.10 because it is 10%, so it is 0.10 divided by 12 because it is monthly. So when it is monthly, m becomes 12. Okay, so m is equal to 12. So 1 plus 0.10 divided by 12, the whole raised to 12 again because it is raised to m minus 1. The answer comes as 0.1047. That is nothing but if you multiply it by 100, okay, decimal, if you want to convert it into percentages, you multiply it by 100. When you multiply it by 100, the percentage comes as 10.47. Now what does that mean? Though the nominal rate that you used was 10%, okay, let me just clear this first. The nominal rate that you used was 10%, but the effective interest rate was 10.47%, because this 10% was on yearly basis, and then you compounded it on a monthly basis. So ultimately your effective interest that you will be applying for any value when it compounds monthly at 10% per annum would be 10.47%. I hope you're clear with this particular concept of effective interest rate, because there are many problems which come there are some problems which come on effective interest rate, so you need to be aware of this. Okay, it's a very simple formula, the same formula of future value of lump sum, only difference is instead of PV, which is not there, we use -1, and N is not used because N is considered as 1 itself. Okay, so I'll just stop with this because I don't want you to get confused with some other concept immediately. So we'll stop over here. Try to solve any annuity for any continuous compounding formula, compounding sum that we have solved previously. You can try to find out the effective interest rate of that, but always remember the year should be considered as 1, that is N should be considered as 1 itself, or N is not considered at all. Since it is 1, it may not be considered at also. Okay, so try to do it. Okay, and if there are any problems, or if you're not understanding this concept of effective interest rate, you can just put it in the group, or you can send me a personal message. I'll be able to solve those doubts. Thank you.